Hi, my name is Dr. English, and today we're going to be talking about atomic structure 1 and specifically subatomic particles. In this tutorial, we are going to focus on what is an element, what is an atom, and going over the subatomic particles, protons, neutrons, electrons, and finally talking a little bit about the nucleus. So first, what is an element? An element is defined as a pure substance that cannot be separated into simpler substances by a chemical change. So if you tried to burn it or put an acid on it or a base on it, it would still be the same element. You cannot break it down into a simpler substance. Now each element is made up of individual atoms. So a bunch of atoms makes up an element. And in these atoms, they will all have the exact same number of protons. We're going to talk more about protons in a second inside their nucleus. And the nucleus is also another thing that we're going to talk about in a minute. So if we look at these images below, which all come from periodictable.com, you'll see different representations of elements. For example, here is the element cesium, and in the element cesium, they all have the exact same atoms that make up this particular element. Now here's a diamond. In this diamond, they all have the same type of atoms that make it up, so it's all carbon atoms. In this representation of copper, which looks like a little copper baby or a copper ball, they all have the same type of atoms that make up this representation of copper. Below we have iodine, which is all made up of iodine atoms, and finally a representation of oxygen, which in this elemental oxygen all has the same type of atoms. So in all of these different type of elements, they all have very specific atoms that make them up as a whole. Now, what is an atom? And knowing what an atom is very, very important. An atom is defined as the basic unit of matter. Everything is composed of atoms. You're composed of atoms, the chair that you might be sitting on is composed of atoms, the things that we eat are composed of atoms. Pretty much everything that exists around us is composed of atoms. And in an atom, there are 3 subatomic particles that you need to be familiar with, and they are protons, neutrons, and electrons. And when I talk about these, you can always refer to Table O of your reference tables to see representations or symbolic representations of these 3 subatomic particles. So let's talk about the first subatomic particle, which is the proton. So a proton is located inside the nucleus of an atom. A proton has a positive charge, so I always like to think of positive and proton. They both start with the letter P, so that's one way of remembering that protons are positive. And the mass of a proton is equal to that of a neutron, which we'll be discussing in a moment. So protons and neutrons have very similar masses. We say that they are both equal to approximately 1 atomic mass unit, which in Regents chemistry we're going to represent as a little u. If you use a textbook, they also might represent an atomic mass unit as an AMU, which is absolutely fine, but for New York State and the Regents exam, we're going to be representing it as a U. So the mass of 1 proton can be represented in terms of atomic mass units. Now, 1 atomic mass unit is defined as 1/12 of a carbon atom. So a carbon-12 atom, and this 12 is going to represent a mass, and we'll talk about that in the future, is the standard by which all other elements in the periodic table are weighed against. So all masses of the elements on the periodic table are defined by carbon. And more importantly, each element has a characteristic number of protons. And what we're going to discover in the future is that if you change the number of protons inside an atom that make up an element, you basically change the identity of that element. There's 2 different representations that we can have of protons that are found on Table O. One is right here where you're going to have a capital H, and we'll talk about symbolic representations in the future. So this is one representation of a proton, and here's another representation of a proton where this lowercase p is representing basically a proton. So as we see in this model down here, the protons are represented by the yellow spheres, and they are inside the nucleus. Now let's talk about a neutron. And the first thing that you need to know about a neutron is they are neutral. In other words, having no charge. So just like protons are positive, P and P, we can think of neutrons basically being neutral, so N and N. Neutral, neutrons, positive, protons, somewhat convenient. Neutrons are also found inside the nucleus of an atom, and what I tell my students is that P and N are relatively close to each other in the alphabet, so we try to keep them together. So we're going to keep them together inside the nucleus. And again, as stated before, the mass of a neutron is equal to that of a proton, which is defined as one atomic mass unit represented by the letter lowercase u. Now on table O of your reference tables, the neutron is represented by a lowercase n, as we see right here. And one more time, in a different model of the atom, the protons and the neutrons are found in the center of the atom, and the electrons are found on the outside, which we'll mention right now. So here we have the electron. What do we need to know about electrons? Well, unlike protons and neutrons, which are found inside the nucleus, an electron is located outside of the nucleus of an atom. Electrons are going to have negative charges associated with them. And the mass, if we wanted to get really specific about an electron, is equal to 1,836th, roughly, of the mass of a proton. So in other words, really, really, really small. In other words, negligible. So the mass of an electron, it does have a mass, is very, very tiny. Now the most current model of the atom describes an electron as being found in regions called orbitals around the nucleus. So if we look at something known as the wave mechanical model right here, we can see a positively charged nucleus in the center, and then the blue dots around them are representing different electrons, and the more dense the blue cloud is closer to the nucleus, the more likely you are to find an electron, and as we go farther and farther away from the nucleus, the less likely we are to find an electron. Electrons have two ways of being represented on table O of your reference tables. One is a capital beta, as we see right here, or another way of representing it is a lowercase e, or sometimes your teacher might represent it like this with more of a cursive e like that. So these are different ways of representing electrons. Finally, we get to the nucleus of an atom, which we've already been talking about, and that is the small concentrated core of an atom. And the only two subatomic particles that are inside the nucleus are, again, protons and neutrons, where protons have a positive charge and neutrons are neutral. So this is where most of the mass of the atom is located. We can't totally disregard the electrons. They do have a tiny bit of mass, so we can't say, oh, all of the mass of the atom is located here. The majority of the mass is located here, with the protons being one atomic mass unit and the neutrons also being one atomic mass unit. Again, we say that the overall charge of the nucleus is positive because, again, protons are positive and neutrons are neutral. Sometimes they might ask you for something known as the nuclear charge. The nuclear charge. And the nuclear charge just asks for the charge on the nucleus. And if you know that neutrons are neutral and therefore do not carry a charge, the nuclear charge is always going to equal your number of protons. So if you ever come across that term in the future, you know what they're talking about. And finally, the nucleus, which is at the center of the atom, is surrounded by negatively charged electrons. So what did we learn in this little brief tutorial? Well, we talked about what is an element. We looked at the definition of an atom. We talked about three subatomic particles, protons, neutrons, and electrons. And finally, we talked about the nucleus of an atom. Need more help? Feel free to contact me. Hope this helped. Have a great day.